At present, most of distributed systems have a high demand. Peer-to-peer systems hold a major part of it. Most of popular peer-to-peer systems are unstructured overlay architecture, but emergence of structured architectures is becoming dominant. Distributed hash tables is a structured peer-to-peer system. The problem with current distributed systems is a trade-off between scalability and stability. Message latencies and low message throughputs are the reasons for these problems. Sinchana distributed hash table attempts to address latency issues prevalent in existing distributed hash tables by introducing the Apache Thrift (RPC) framework. Apache Thrift uses a binary message format to marshal data used by remote method invocations. It uses smaller message size, consumes less CPU process time compared to other RPC frameworks. This enables high throughput and reduced message overhead, resulting in increase in scalability and stability. Sinchana distributed hash table is implemented with three DHT routing algorithms similar to the existing code tapestry and pastry. There will be a plug-and-play interface to select which algorithms that will be used in distributed hash table. With this interface, developers have the chance to test any of these algorithms under the same communication framework. They can also find out which algorithms give high performance for a given scenario. The Sinchana distributed hash table acts as a framework for other developers who might need to use this distributed hash table and build their own peer-to-peer application on top of it. Sinchana distributed hash table is implemented in a way that the routing algorithm is decoupled from the other mechanisms like message handling, connections handling, data storing, etc. This gives a chance to integrate new routing algorithms to the Sinchana DHT quite easily. The ring topology has the highest static resilience. Sinchana uses a ring to route messages through node predecessors or successors in handling route table failures for all three protocols. This increases the stability of Sinchana distributed hash table and causes less message drops and increases the lookup success ratio. Message failures in distributed hash tables are found usually by continuous trying using timeouts. This is a time-consuming process and causes delays in message sending and object lookups. Sinchana DHT enables a failure message acknowledgement mechanism where an acknowledgement message is sent to sender from the failed point. That enables Sinchana DHT to perform its recovery algorithms faster. Sinchana distributed hash table has a sophisticated design where each component is integrated to each other easily. Sinchana DHT contains a comprehensive API that provides details of method calls that can be used to publish resources and services conveniently to front-end applications that run on top of the Sinchana overlay network. This effectively decouples the user application from the underlying peer-to-peer routing and lookup system. The API is simple to understand, easy to use, and unambiguous. Thus, developers can use it efficiently in developing distributed P2P applications. Request Handler. This will handle all the requests in one node. This will match a response to its relevant request using the ID map and forward it to the next suitable node. Sinchana Message Handler. Nodes communicate only using messages. Upon the arrival of a message at a given node, the message is processed by the message handler. The message handler alerts the application via an app call if requested. A message handler processes messages based on its type, which can be a join or a get message. Sinchana routing table. Each node maintains a routing table, which is a data structure consisting of a set of neighbor entries, each of which contains the IP address and identifier of some of the other node. The routing table is used to compute the next hop when forwarding lookup queries and messages. A DHT node maintains its routing table by populating it initially and ensuring aliveness of its neighbors. I/O handler. This will handle all the I/O operations on one node. This contains thrift server and client. Thrift server is responsible for creating, initiating a host. Further, it enables a host to leave the system gracefully. It also manages connection to other nodes and responsible for transport layer messaging passing. Thrift client is responsible for communicating with the Thrift server. It initiates a connection in order to pass a message between two nodes. Connection pool. A connection pool is used by each and every node in the system. The connection pool consists of a set of connections made to the neighborhood nodes identified from the routing table of each node. Throughput drops steadily as expected, but the rate of decreasing the throughput reduces with network size. This is expected as the number of hops per message path increases as the network size grows. This increasing in hops increases the response time for a message sent, gradually reducing throughput. Importance in Sinchana DHT implementation stand above the existing DHT in average throughput and response time in all the time. This can further see in content storing and retrieval as both of them depend on underlying message service framework. Both two cases, Sinjana pass-through implementation shows less drop lookups. The gap between Sinjana and free pasty further increases when the network size grows. This shows that Sinjana pass-through has a better fault tolerance capability than free pasty. The main reason for less drop lookups in Sinchana tapestry uses pasty ring to forward messages to closest neighbor when it's find a hole in the routing table and unable to pass the message under the normal routing. Sinchana distributed hash table serves as a middleware for distributed applications. It can be used for many scalable distributed applications and to build more complex services such as Anycast, cooperative, web caching, distributed file systems, domain name services, messaging, multicast, and also peer-to-peer file sharing system and content distribution system.